Ever wondered how electricity is generated from coal? Well, it's a fascinating process that combines science, technology, and a dose of nature's own resources. Let's embark on this journey of understanding together. Coal, a black or brownish-black sedimentary rock, is primarily composed of carbon, along with various other elements such as hydrogen, sulfur, oxygen, and nitrogen. It's formed from the remains of plants that lived and died millions of years ago, compressed under high pressure and extreme temperatures. But how does this ancient carbon-rich material play a role in powering our modern world? Imagine a world without electricity. It's difficult, isn't it? Electricity powers our homes, our industries, our hospitals, and schools. It lights up our cities and drives our economies. Coal plays a crucial role in this scenario as one of the most abundant and affordable sources of electricity across the globe. When burnt, coal releases energy in the form of heat. This heat is used to produce steam, which in turn drives turbines connected to generators. When these turbines spin, they generate electricity that powers our lives. It's like a giant, super hot kettle boiling water to create steam that spins a wheel. But why coal? Why not other resources? Well, coal is not only abundant, but also relatively easy to extract compared to other fossil fuels. This makes it a significant contributor to the global energy mix, providing a whopping 40% of the world's electricity. But this doesn't mean coal is without its challenges. Generating electricity from coal has environmental impacts, including the release of harmful pollutants. But fear not, for technology and innovation have provided us with ways to mitigate these effects, which we'll explore in the following scenes. Now that we understand what coal is and its significance, let's dive into the process of turning coal into electricity. Just like a magician revealing his tricks, we'll unravel the mystery behind this dark, ancient rock and its role in lighting up our world. So buckle up and get ready for an electrifying journey. Our coal extraction is the first step in the process of electricity generation. It's a fascinating process that involves a complex system of mining and transportation. Let's delve into it. Coal, a black or brownish-black sedimentary rock, is primarily found in underground deposits. These deposits are accessed through either surface mines or underground mines. The choice of mining method is largely determined by the geology of the coal deposit. Once the coal is mined, it needs to be transported efficiently to the power plants where it will be used for electricity generation. This is where the conveyor belt system comes into play. Imagine a giant continuous loop of belt made from materials like rubber, PVC, or other synthetic materials. This belt is stretched across a series of powerful rotating rollers that move the belt along, carrying with it the precious cargo of coal. But how does the turbine spins? It also turns the generator. Inside the generator, there's a magnet and a coil of wire. As the magnet spins inside the coil, it creates an electric current, and voila, we have electricity. But remember that pot of water on the stove? After a while, the water levels go down. The same happens in our power plant. As the water turns into steam, the water levels in the boiler go down. More water is then pumped into the boiler to keep the process going. So the role of water in producing electricity from coal is twofold. First, it turns into steam that drives the turbine. And second, it helps to keep the system cool by absorbing the heat. After this process, we have electricity. But what happens to the leftover water? Water is a crucial resource in electricity generation. But how is it managed after use? After water has played its role in the steam generation and cooling processes within the power plant, it doesn't simply get discarded. Instead, it undergoes a thorough filtration process to be reused again, ensuring efficiency and sustainability. The first step in this filtration process is the sedimentation phase. Here, the used water is left undisturbed in large sedimentation tanks. Over time, the heavier particles settle at the bottom while the lighter ones float to the top. After sedimentation, the water then moves on to the filtration stage. This involves passing the water through layers of sand, gravel, and sometimes activated charcoal, all of which act as sieves to remove smaller particles that manage to survive the sedimentation process. However, the filtration process isn't quite finished yet. To ensure the water is thoroughly clean, it undergoes a disinfection phase. This usually involves treating the water with chemicals, heat, or ultraviolet light to kill any remaining microorganisms. Once disinfected, the water is then treated with coagulants, chemicals that cause the remaining particles to clump together for easier removal. After this final cleansing, the water is now ready to be reused within the power plant. This water filtration and reuse system is a testament to the power industry's commitment to sustainability. By reusing water in this way, we're not only conserving a precious resource, but also minimizing the environmental impact of power generation. But this isn't where the story ends. Even after the water is cleaned and ready for reuse, it's continuously monitored to ensure it meets the highest safety standards. This involves checking the water's pH levels, temperature, and other important parameters to ensure it's fit for purpose and safe for the environment. With water managed efficiently, we must now consider another crucial aspect: pollution. Coal-based electricity generation isn't without its challenges, one of which is pollution. The burning of coal releases a number of harmful substances into the environment, such as sulfur dioxide and nitrogen oxides, not to mention the significant carbon dioxide emissions that contribute to global warming. But you may wonder, how do we control this pollution? Well, power plants are equipped with advanced technologies to limit these emissions. These include scrubbers, which remove sulfur dioxide from the flue gas, and selective catalytic reduction systems that reduce nitrogen oxide emissions. Carbon capture and storage technologies are also being developed to trap carbon dioxide and store it underground. There's also the issue of coal ash, a byproduct of coal combustion that can contain toxic substances. To manage this, many power plants use coal ash recycling strategies, converting it into useful materials like concrete or wallboard. Now, let's talk about daily coal consumption. Globally, millions of tons of coal are burned every day for electricity generation. This massive consumption has significant implications, not only for the environment, but also for the economy and public health. Firstly, the extraction and transport of such large quantities of coal can lead to land degradation and water pollution. Economically, reliance on coal can make countries vulnerable to price fluctuations and supply disruptions. And let's not forget the public health concerns associated with air pollution from coal combustion, which include respiratory illnesses and premature deaths. However, the transition to cleaner energy sources is not something that can happen overnight. Coal still plays a significant role in meeting the world's energy needs, particularly in developing countries where alternatives may not be readily available or affordable. Therefore, while we strive towards a cleaner, more sustainable energy future, it's crucial that we continue to improve pollution control measures in coal-fired power plants. While coal plays a crucial role in electricity generation, it's important to manage its impact on the environment effectively.